I'm going to go through this question two ways, like quite a nice quick way and then a longer way that involves speed equals distance over time. I'm always tempted to use that myself when I do these questions. It got me there, so that's the main thing, but I do appreciate the other method, this method I'm showing you now. All right, we've got this race and it's starting here at the bottom and we're going to the top and we're told it's 5 kilometers. But the hare actually goes east and then realizes made a mistake and makes a beeline to the end point. So we don't know how far they go, and actually that's what we want to find out. We want to find out the distance between the hare's turning point and the finishing point, so y. That's what we want to find out. Um, Now here's the thing. The tortoise goes 5 kilometers, and the hare goes x plus y. They travel along here and then up here. But they go 5 times as fast, which means that x plus y, because they arrive at the same time, must be 1/5 of the distance. So that's a little equation that we can set up. And therefore, 25 is equal to x plus y if I just multiply through by 5. However, furthermore, using Pythagoras' theorem, we've got 5 squared plus x squared, or 25 plus x squared, is equal to y squared, which I can rearrange to 25 is equal to y squared minus x squared. So I've got simultaneous equations now, actually, involving a quadratic. You could substitute in for x or y, but there's actually a quicker way. This is a difference of two squares. So it's going to be y plus x, y minus x. And that is really useful in this case because we have that y plus x is 25. There we go. So if I divide through by 25, we get y minus x equals 1. That's not a general method for solving quadratic simultaneous equations, but it works here because actually this is a difference of two squares and involves that one there. So now we're left with simultaneous equations. We've got y minus x is 1 and y plus x is 25. So if I add them together, I've got 2y is equal to 26, and therefore y is equal to 13. Here comes method 2, a little bit more complex, but it does the job, and it's not that bad. So I've got the triangle again, and we've got a distance of 5, but I didn't really focus on the distance. I just focused on the time that it takes the tortoise. So the time that it takes the tortoise is going to be distance over speed. So 5 over the speed of the tortoise. Okay, so in this method, I kind of work with some unknowns. I'm not interested in what v is, but it's going to kind of help me get there. And now I'm still going to call this one x. Let me just label 5x, and I won't go with y for the moment because I'll show you what I did. So the time to go along here for the hare is going to be the distance divided by 5v. Okay, nice one. And then over here, well, the distance is actually going to be the square root of x squared plus 25 using Pythagoras' theorem. And so the time is going to be that distance, again, divided by 5v. And then, because we know they finish at the same time, we can create an equation. 5 over v must equal x over 5v plus the square root of x squared plus 25 over 5v. Now I'm just realizing, this is how I did it. I'm just realizing I probably should have called this one here y, because that is the one I want to find. And then I could have used Pythagoras on this one. So I'm actually going to find x, and then I'm going to have to find x squared plus root 25 from it. But when I did the problem, I wasn't really thinking about it. I was just thinking, let's go with a method. All right, I can cross out the v's because it doesn't actually matter. The fact that one is going 5 times the other is enough information to use. And then multiply through by 5. So 25 is going to equal x plus root x squared plus 25. If I minus x from both sides, I've got to get rid of the square root. And I get this. Now I can square both sides. So it's going to be a double bracket. I'm going to do 25 times 25. I'm going to do 25 times x twice. So I got 50x, and I've got x squared equals x squared plus 25. So if I did that too quickly, let me just show you up here. 25 minus x times 25 minus x. So I've just done 25 times 25, 25 times minus x, and 25 times minus x again, and then minus x times minus x. So these cancel out, brilliant. And then I can add 50x to both sides and minus 25. So 50x is going to equal 600. Nearly there. Can divide through by 10. We can see that x is 12. So finally, although, yeah, like I said, I should have just solved for this one originally. I've got 12 here, I've got 5 here, and I can use Pythagoras' theorem, or actually might know that it's a Pythagorean triple, 5, 12, and 13. It's worth knowing a few of these, like 3, 4, 5 is the classic one. But if you double it, you get 6, 8, 10. These are all Pythagorean triples. 3 squared plus 4 squared is 5 squared, and so on. But if not, just use Pythagoras' theorem and you will get 13 as the answer, which we got before. So yeah, it's solid. Like especially if you do not see quick methods for doing these questions, and remember you're under time pressure in the real thing, using a tried and tested method that might be a little bit more clunkier but gets the job done is worth being aware of. Thanks.